Okay, ladies and gentlemen, let's see how you did on this stuff. We had, 18 problems to do. I know this went down to 19, and I don't know if everyone did 19 or not, but that one might have been kind of crazy and everybody freaked out about it. I meant to have you only do 1 through 18. Let's see here. We'll do that. All right. So we're going to look at these. These first 6 are all based off this picture and all based off, you don't even really need the picture as much as you need the similarity statement. As long as you have that, you can answer the information. Okay, so for number 1, it says angle D is congruent to what? Well, angle D corresponds in the list to angle H. So angle D is congruent to angle H. Okay, number 2 says angle Y is congruent. Well, angle Y corresponds to R. So you say angle Y is congruent to angle R. Number 3, angle T. Angle T in the list is the last one, so that corresponds to angle X. We know with similar polygons that corresponding angles are congruent. So these are the angles that correspond to each other. On number 4, it says JD, which is that left side, is to JH, which is the smaller left side, in the same way that DR, the top, is to, and it would be DR is to HY, the smaller top. Okay, on number 5, it says RT, which is the large right side, is to YX, the smaller right side, in the same way that something is to JX. Now, JX is the small bottom, so then we'd be looking at JT. Okay, number 6 says blank is to DR, DR being the top of the large one, in the same way that YX, the small right side, is to RT, the large right side. So that would be that HY. HY is to DR. Okay, moving on. 7 and 8, the question is, are these similar? Okay, and so you know they're similar if you got to have those two things. You got to have corresponding angles are congruent. Well, for this one, we have 90, 90, 90, 90, and 90, 90, 90, 90. So corresponding angles are congruent. Check. But then we need corresponding sides to be proportional. So we say, well, okay, well here these sides 20 to 30 give me a ratio of 2 to 3, and the other side 36 to 52. Well, how do those reduce? Let's see. 6 does not go into both of those. 4 does. 4 goes into both of those. 4 goes into 36 9 times. 4 goes into 52 13 times. Well, 2/3 is not the same ratio as 9/13. So the sides are not proportional. We would need those two fractions to match up, and they don't. So the answer is no. And why? Because it says explain. Because the sides are not proportional. Okay, number 8. Again, here we go. Okay, this angle is congruent to this angle, which is congruent to this one, congruent to this one. And then this one's congruent to this one, congruent to this one, and this one. So we've got these isosceles trapezoids, and the corresponding angles are congruent. We're good there, okay? So now we got to check to see if the corresponding sides are proportional. So we can say, well, the smallest side here, 6 is to 8, and that would reduce to 3/4. Okay, and then we've got the top, which would be 7.5 is to 10, and that also reduces to 3/4. And then we've got the bottom, which would be 12 over 16, which also reduces to 3/4. So we got 3/4, 3/4, and 3/4. And then all the corresponding angles are congruent, so therefore we have similar figures, but we got to name it. It says write a similarity statement. So I'm going to say RQTS. So I started at the bottom, went up one of the short sides, across top, is similar to WXYZ. Okay? Awesome. That's what we should have. All right. And so those are similar. Okay, moving on. Numbers 9 and 10. Again, it says, are these similar? Okay, and so we're checking for the same thing. We're just checking for the same information. This first one, of course, the corresponding angles are congruent. We've got all 90s. So the only other thing to check is, are the corresponding sides proportional? So we say small side to small side, 15 to 25, which is 3/5. And then larger side to larger side, 18 to 30, both divisible by 6, which is 3/5. So answer is yes. We're supposed to write a similarity statement. So we say KJML, I went across a short side, across a long side, across short side, is to NQPO. Now your similarity statement can differ a little bit because you could have started in a different spot, but they still have to correspond. Okay, so the side KJ corresponds to the side NQ. KJ is the smaller side and NQ is the smaller side. So there's some connection there. Okay, with number 10, these have got to be each a rhombus. because all the sides are congruent. And so if those angles are 110 in that first one, that means this one has to be 70 and this one has to be 70 because consecutive angles would be supplementary. And that would mean that this has to be 110 and this has to be 110 because consecutive angles are supplementary. So we've got congruent corresponding angles, and then 8 is to 10, which we reduce to 4/5, but that's the ratio of all of the sides. And so the answer is, once again, yes. Those are similar. So I could say that ABCD is similar to, now I started at one of the obtuse angles, so I can say FGHE. Okay? All right, next one. Again, these are each a rhombus. However, these say 100 degrees, which would leave 80 for this one and 80 for this one. And so then we have 100 and we have 80. So those angles clearly don't match. So the answer is no, because the corresponding angles are not congruent. All right. And then for number 12, okay, we've got that this angle is congruent to this one's congruent to this one, and this one's congruent to this one. So we have corresponding angles are congruent. So now we just check the sides. So, okay, it's 2.5, have the same relationship with 3.5. That reduces to 5/7. And then we could say, whoop, that just kind of jumped. Let's try that again. We've got 6.0 is to 8.4, and that does reduce. 1.2 goes into each one of those, which would reduce to 5/7. And then the last one would be 4.5 and 6.3, and that once again, that reduces to 5/7. So yes, all of the corresponding sides are proportional. So I could say that triangle ABC is similar to triangle FED. Okay, moving on. Now, 13 through 16, it says the polygons are similar. We don't have to figure that part out, but it wants us to find the value of each variable. Okay, so for 13, I could say I know that 8 has the same relationship with x in the same way that 10 does with 5. Okay, and then I cross multiply and I get that 10x is equal to 40, so therefore x is equal to 4. For number 14, I've got 3 different variables. Oh, I'm sorry, I had more in number 13. I didn't solve for y. So I could say 6 is to y in the same way that 10 is to 5. Again, cross multiply and solve, and I get that 10y is equal to 30, so therefore y is equal to 3. So x is equal to 4 and y is equal to 3. Number 14, let's see here. Number 14, I'm going to say I got to find some relationship, some sides that I have, corresponding sides. I've got 5 and I've got 10. So I can say 5 is to 10 the same way that 10 right here is to x. 10 is to x. Cross multiply. 5x is equal to 100, so therefore x is equal to 20. Okay, in the same way, I can say 5 is to 10, just like z is to 15. Just like z is to 15. And I go, okay, cross multiply, and this time I get 10z is equal to 75, so therefore z is equal to 7.5. All right. And then the last one, I would again start the same way. 5 is to 10 the same way. And I'm looking for some kind of connection. Y is to 35. Cross multiply. 10y is equal to 175. So therefore, y is equal to 17.5. Okay? So that's number 14. Number 15. Real similar. Okay? So I don't want to move too slowly and take forever on these. But very, very similar problem. Let me get rid of some of this stuff right here. Okay, so I could say for number 15, 10 is to z, the same way that, well, I need to have, before I get this going, I need to have a set of sides that already correspond, that have all the information. So like 8 and 6 correspond. So I could say 8 is to 6, the same way that 10 is to z. Cross multiply, and that gives me 8z is equal to 60, so therefore z is equal to 7.5. Okay? Again, I could say 8 is to 6 the same way that x is to 12. And that would give me 6x. All right, 6x is equal to, 96. So therefore, x is equal to 16. And once again, I could say 8 is to 6 the same way that, let's see, how about 6 is to y. And that would give me 8y is equal to 36, so therefore y is equal to 4.5. Okay. Number 16. Let's see here. Again, we've got 3 variables. I got to find a set of sides that correspond to each other, that I have all the information. So I see the 6 and the 9. So that's what I'm going to keep doing. I'm going to go 6 is to 9 the same way that 4 is to x. Okay, the same way that 4 is to x. So cross multiply, 6x is equal to 36, x is equal to 6. Once again, I'll say 6 is to 9 the same way that this time z, oof, that's an ugly z, is to 15. Cross multiply, and I get that 9z is equal to 90, so therefore z is equal to 10. Okay? And then lastly, I could say 6 is to 9 the same way that y is to 12. Cross multiply, and I get 9y is equal to 72, so therefore y is equal to 8. So there's your values. X is 6, y is 8, and z is 10. Okay, the last 2, these were this idea of like, if you want to blow something up or shrink something down, how can you fit it on this other thing? But you got to make sure that it does actually fit. Okay, so we're going to try that. Get rid of all that. Boom. Okay, so for number 17, it says you want an enlargement. It already is 3 by 5. We want to get it on an 8.5 by 11. So first thing we do is we check and see, does that work as it is? Do we have to change it? Can we go 3 is to 5 the same way that 8.5 is to 11? And we cross multiply, we get 33 is equal to 5 times 8.5 is what, 42.5. And so clearly those two are not the same. Okay, so that doesn't work. But so then what we do is we say, well, we need the 3 to 5 ratio to stick around. So we go, maybe let's take out the 8.5 and keep the 11. Or we need the 3 to 5 to stick around. We keep the 8.5 and we get rid of the 11. Okay? And we cross multiply and solve for each one of these. So this first one would give me 5x is equal to 33. So therefore x is equal to 6.6. This next one I would say 3x is equal to 42.5. So therefore x is equal to 42.5 divided by 3. Yuck. That's like 14 and a sixth. Okay. Okay, now, so we look and go, which one of these works? And while this one is larger because it would be 8.5 by 14 and a 6, that's a problem because that doesn't fit on the sheet of paper. So the one we want is actually right here. We want this one that's 6.6 by 11. That's the biggest enlargement we can get. Okay, and lastly, number 18. A map has dimensions of 9 by 15. You want to reduce it so it'll fit on a 4 by 6 index card. So we have 9 by 15, and we're trying to reduce it to 4 by 6. Let's see here. Make that go away. There we go. Okay. So first thing, we always check to see, does it work as it is? Well, 9 times 6 is 54. 15 times 4 is 60. It does not work. So then we want to keep the 9 by 15, and maybe we get rid of the 4 and keep the 6. Or we have the 9 by 15, we keep the 4 and get rid of the 6. Cross multiply, and you get that 15x is equal to 54, or that 9x is equal to 60. Okay, in this case, x would equal, let's see, 15 goes into 54 3 times with 9 left over. So it'd be 3 and 9/15, which is the same thing as 3 and 3/5, or 3.3. And then divide 60 by 9, and we get x is equal to 60 over 9, which is the same thing as 20 thirds, which is 6 2/3. So we go, which one of those works? Well, we either have 3.3 by 6, or, I shouldn't have written that as a fraction, maybe a little bit harder to understand that way. We can either have 3.3 by 6, or we can have 4 by 6 2/3. Okay? And again, we run into the problem that this will not fit on the 4 by 6 card, but this one will. So that's the size we want. All right. I know I moved quickly, but we did a lot of examples, so hopefully this made sense. We're going to do more practice, and if we need to watch this again, go for it.